My seminar topic is subbasis for a topology. Subbasis for a topology. First I begin with definition. Let X be a set. A subbasis for a topology on X is a collection S of subsets of X such that union of elements of S belongs to S equal to X. Recall the definition of basis of a topology. In all the three definitions, in collection of subsets of X for a topology, there are three conditions. For basis, there were two conditions. For subbasis, only one condition. Union of elements of S equal to X. For example, X equal to A, B, C. Let collection SB equal to collection of subset AB, namely BC. AB, BC. S1, S2 ಅಂತ ಡಿನೋಟ್ ಮಾಡಿದ್ರೆ S1 ಯೂನಿಯನ್ S2 ಏನಾಗುತ್ತೆ equal to X. S1 union S2 equal to X. Therefore, union of S1 S2 is equal to X. S is a subbasis. For a topology on X. Now we have to prove one lemma. Let S be a subbasis for a topology on X, and let B be a collection of all finite intersections of elements of S. All finite intersection we note. All finite intersection 2 points we have to noted. We take 1 element, or 2 element, or 3 element. At a time we take finitely many times. Then the lemma says that B is a basis for a topology on X. Proof. To prove that B is a basis, we have B equal to set of all finite intersection S1 intersection S2 intersection Sn, where Si are elements of S, 1 less than or equal to I less than or equal to n. Finite intersections. If n equal to 1, then S1 belongs to B. That is, one element, if you take one element each time, there will be one element in the intersection. It has to be viewed as finite intersection of elements of S. Therefore, it is an elements of B. Therefore, the elements of S are elements of B. That is the first point to be noted. Next, take x in X arbitrary, because we want to prove that B is a basis. We have to verify two conditions. In the first condition, begin with the element of S. If X belongs to X, then X belongs to union of elements of S, because X is a subbasis. This implies that X belongs to S for some S. But S belongs to S. S is an element of B, because every element of S is an element of B. So S belongs to B. Therefore, first condition is satisfied. Next, to verify the second condition, let take two elements. Take two elements B1 and B2. B any two elements of B. Take any two elements. They look like B1 equal to S1 intersection S2 intersection Sn, where 1 less than or equal to I less than or equal to n. For each Si belongs to S. Si's are elements of S. B2 is again a finitely intersection of elements of S. S2 intersection S2 prime intersection Sm prime. Finitely many sets ಇರುತ್ತೆ ಇಲ್ಲಿ. For 1 less than or equal to I, j less than or equal to m. Sj are elements of S. Then B1 intersection B2 is equals to S1 intersection S2 intersection Sn intersection S1 prime intersection etc. Sm prime. Note that there are n plus m elements. Finite intersection of elements of S. because it is a finite intersection of elements of S. It is an element of B. By definition of B, because it is a finite intersection of elements of S, so by it is belongs to B. Intersection of B, two elements is again an element of B. Therefore, second condition is satisfied. Therefore, B is a basis for a topology. This topology is called the topology generated by S. ಬಿ ಬೇಸಿಸ್ ಆಗುತ್ತಲ್ವ, ಒಂದು ಟೋಪಾಲಜಿ ಬರುತ್ತೆ, ಆ ಟೋಪಾಲಜಿನ ಟೋಪಾಲಜಿ ಜನರೇಟೆಡ್ ಬೈ ಎಸ್ ಅಂತ ಕರಿತೀವಿ. ಟೋಪಾಲಜಿ ಜನರೇಟೆಡ್ ಬೈ ಬಿ ಈಸ್ ದಿ ಕಲೆಕ್ಷನ್ ಆಫ್ ಆಲ್ ಯೂನಿಯನ್ ಆಫ್ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ ಬಿ. Each element of B is finite intersection of elements of S. Combining the two, we observe that the elements of topology are unions of the finite intersection intersections of elements of S. Unions of finite intersection of elements of S. Elements of the topology are unions of the finite intersection of the elements of S. That's how we describe how topology we see the elements of the topology generated by subbases. Now look at the example. We take let X to be equal to set consisting of A, B and C. A, B and C. Let S be equal to A, B, B, C. A, B, B, C. Then union of these two elements equal to A, B union B, C equal to X. Therefore, S is a subbasis. Collection is a subbasis. This is how we show that collection is a subbasis. The basis is you take finite intersection of elements of S. You take the intersection of this set with this set, we get same. You intersect these two, we get two same. B, AB and BC. Note that S is not a basis. S is only a subbasis. Look at the two elements. You take their intersection. B belong to their intersection, but there is no element collection containing their containing elements. So it is not a basis. Basis is this. So this is a basis, a topology generated by B and hence generated by S is tau. All union of elements of S. You take the union, you get empty set X, B, elements of B or elements of topology. Therefore, we look at S, B, and then tau. S, B and tau. We note that S is a subcollection of B is a subcollection of tau. So this is a basis of a topology. This is not a topology. Basis need not be a topology. Topology need not be a basis. This is one example. In the second example, I will take, let X equal to R, and I take collection to be collection of all rays a plus infinity, where A belongs to R, and also collection minus infinity where A belongs to R. So this is the collection. All open rays of this type and all open rays of this type. Now we take two elements. Minus infinity 1, it is an element of this type, and 1 plus infinity, an element of this type. Take their union. Don't we get minus infinity to plus infinity? Sorry, this one 0. 1 ಇಲ್ಲಿ ಇರೋದಿಲ್ಲ. We get minus infinity. So 1 ಗಿಂತ ಚಿಕ್ಕಾಗಿರೋದು ತಗೋಬೇಕು. This one is 0. 0.1, 0.1, 0.2 for any, that equal to R. We take unions of, therefore unions of S, elements of S equal to R. Therefore S is a subbasis. Now topology generated by subbasis is topology generated by the basis. What are the elements of B? B equal to, further we take two real numbers with A less than B. I consider minus infinity B an element of this type and A plus infinity element of this type. I will take their intersection. Don't we get A minus infinity in the B ವರೆಗೆ, A in the plus infinity ವರೆಗೆ. Their intersection is this, AB. Therefore we get all open intervals AB, open interval AB, finite intersections of elements of S. Therefore, finite intersection of elements of S are elements of form AB, open interval AB. The topology generated by open interval set of all or collection of intervals is less than the topology. Therefore, the topology generated by S is the topology generated by the collection of all open intervals. Open intervals ಬರುತ್ತೆ. ಓಪನ್ ಇಂಟರ್ವಲ್ಸ್ ಜೊತೆ ರೇಸು ಇರುತ್ತೆ. ಬಟ್ ಆದರೆ ಡೋಸ್ ನಾಟ್ ಮ್ಯಾಟರ್. ಓಪನ್ ಇಂಟರ್ವಲ್ಸ್ ಬಂದರೆ ಸಾಕು, ರೇಸ್ ಬರುತ್ತಲ್ಲೂ. Therefore, the topology is the standard topology. So what is our conclusion is that if we consider collection of all rays of the is type, then they form subbasis for a topology on R. The topology is standard topology. This is an important thing to be noted. This is a subbasis for standard topology on R.